Hello and welcome to this video. As you know, I have not recorded videos for some time because I was sick. It was a long sickness, but now I have recovered and I'm good. I'm in good health. So we will resume the playlist and I will try to make regular videos, but no promises. So we had solved till problem 60 and so we will solve from problem 61. So as always, I say that when I'm stating the problem, you should pause the video and only if you cannot solve the problem, look at the solution. The other time when you should look at the solution is when you want to match the answer. Otherwise, you should not look at the solution. So without further ado, let's get started. We will solve 10 problems in this video and that's it. So question 61 says that if alpha plus beta plus gamma is equal to 4, alpha square plus beta square plus gamma square is equal to 7, alpha cube plus beta cube plus gamma cube is equal to 28, find alpha to the power 4 plus beta to the power 4 plus gamma to the power 4 and alpha to the power 5 plus beta to the power 5 plus gamma to the power 5. So we consider a cubic equation because we have three roots, alpha, beta, gamma. We consider a cubic equation which is x cube plus ax square plus bx plus c. So from Vieta's relations, a is equal to minus alpha plus beta plus gamma, which is given as 4. So it becomes minus 4. Now alpha beta plus beta gamma plus gamma alpha is nothing but alpha plus beta plus gamma whole square minus alpha square beta square plus gamma square by 2. Now alpha plus beta plus gamma is 4, so square is 16, and alpha square plus beta square plus gamma square is given as 7, so that is 7. So 16 minus 7 by 2 is equal to 9 by 2. So this is the value of B in this case. Now we put alpha beta gamma in the given in this equation and we add that. So we get alpha cube plus beta cube plus gamma cube minus 4 into alpha square plus beta square plus gamma square plus 9 by 2 alpha plus beta plus gamma plus 3c is equal to 0. So we have the values for A and B, and for other additions also we substitute those and we get 3c is equal to minus 18, that is c is equal to minus 6. Now once we have c, we can multiply the given equation by x and x square like previous problems and put x is equal to alpha beta gamma and then add to find alpha to the power 4 plus beta to the power 4 plus gamma to the power 4 and alpha to the power 5 plus beta to the power 5 plus gamma to the power 5, which will be equal to 209 by 2 and 334. Question 62 says that solve x cube plus y cube plus z cube is equal to a cube, x square plus y square plus z square is equal to a square, and x plus y plus z is equal to a in terms of a. So one of the solutions is x is equal to a by simple observation, y is equal to 0, z is equal to 0. The second solution could be x and z equal to 0 and y is equal to a. And another solution would be x and y equal to 0 and z is equal to a. That is simply by observation we can figure out that solution. Let's see if we can find other solutions for this equation. So in this case, we have x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus yz plus zx. Now x plus y plus z is a, so whole square is a square, and x square plus y square plus z square is also a square. That there is an extra plus here. That means 2 into xy plus yz plus zx is equal to 0. Now x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now this is a cube, and this is a square, and this is 0. So that means xyz will be 0. Now xyz is equal to 0 means one of x, y or z is 0. If we substitute x is equal to 0, y plus z becomes a, and y square plus z square is equal to a square, which is equal to a minus z whole square plus z square is equal to a square. Okay, because from here we substitute y is equal to a minus z. So that means 2z square minus 2za is equal to 0. That is z is equal to 0. Okay, that is the only value which will satisfy. And that implies y is equal to a comma 0. So you see, we have got three solutions for xyz. That is from our observation, and we don't find any extra roots. So there are 3 solutions for this. Question 63 says that if alpha, beta, gamma be the roots of 2x cube plus x square plus x plus 1 is equal to 0, show that 1 by beta cube plus 1 by gamma cube minus 1 by alpha cube into 1 by gamma cube plus 1 by alpha cube minus 1 by beta cube into 1 by alpha cube plus 1 by beta cube minus 1 by gamma cube is equal to 16. So we have the given equation 2x cube plus x square plus x plus 1 is equal to 0. So we multiply this with x minus 1 and we write x cube power separately. So we have x cube into x minus 1 plus x minus 1 into x cube plus x square plus x plus 1. Now this gives us 2x to the power 4 minus x cube minus 1 is equal to 0. That means 1 by x cube is equal to 2x minus 1. So 1 by alpha cube will be 2 alpha minus 1, 1 by beta cube is equal to 2 beta minus 1, and 1 by gamma cube is equal to 2 gamma minus 1. So our given equation becomes E is equal to, we have let E is equal to given equation is equal to 2 beta plus 2 gamma minus 2 alpha minus 1 into 2 beta plus 2 alpha minus 2 gamma minus 1 into 2 alpha plus 2 gamma minus 2 beta minus 1. And from Vieta's relations, if you look at this equation, alpha plus beta plus gamma is equal to minus half. So the given equation becomes minus 8 into 2 alpha plus 1 into 2 beta plus 1 into 2 gamma plus 1. Now we know the values of this, that is 1 by alpha cube, beta cube, gamma cube from here. So this equation, when you evaluate, it becomes is equal to minus 16. Now question 64 says that find xy such that x to the power 5 plus y to the power 5 is equal to 275, x plus y is equal to 5. Here this C implies in set of complex numbers. So by observation, we figure out that x is equal to 2 and y is equal to 3, or x is equal to 3, y is equal to 2 are two possible roots. Then what we do is, we have here x is plus y is equal to 5. So we take y is equal to 5 minus x and substitute on the left hand side. So that equation becomes x square minus 5x plus 19 into x minus 2 into x minus 3 is equal to 0. Now x is equal to 2, 3 is what we have obtained. For this equation, x square minus 5x plus 19, the roots are complex conjugates, that is 5 plus minus square root of 51i by 2. So we have got 4 roots for this pair of equations. Question 65 says that find real x such that fourth root of 97 minus x plus fourth root of x is equal to 5. Now we let the given terms as a and b. So a plus b is 5. Now we are given that, not given, again we raise each to the power 4. So we get a to the power 4 plus b to the power 4 is equal to 97. Once we have that, we know that a to the power 4 plus b to the power 4 is a square plus b square whole square minus 2a square b square. Again, a square plus b square is a plus b whole square minus 2ab whole square. So a plus b whole square is 5 to the power square, that is 25, minus 2ab. So this we square and further we evaluate, we get 625 minus 100ab plus 2a square b square is equal to 97. So then we evaluate and we get ab minus 25 whole square is equal to 361. 361 is the square of 19. So it could be plus 19 or minus 19 square. So if it is plus 19, then AB is 44, which is not possible. And if we put minus 19, then it becomes equal to 6. So once we have AB as 6, we find given x as, if we put 6 here, sorry, not here, AB is 6, then this equation will give us what? 4 and 9 as the solution. So from here we get x is equal to 16, and 16 if you put in this one, you get 81 as the answer. So we have two values for x, 16 and 81. So this is 2 to the power 4 and this is 3 to the power 4. And the sum would be 97 as indicated here. Question 66 says that find the common roots of the polynomial x cube plus x square minus 2x minus 2 and x cube minus x square minus 2x plus 2. So if you look at the HCF of the given polynomials, it is x square minus 2, which you can find out. And hence the common roots of the given polynomials are the roots of x square minus 2 is equal to 0, that is plus minus square root of 2. Question 67 says that find the common roots of x to the power 4 plus 5x cube minus 22x square minus 50x plus 132 is equal to 0. And x to the power 4 plus x cube minus 20x square plus 16x plus 24 is equal to 0 and solve the equations. So we have to find the common roots and the solutions of the equation. So HCF in this case is x square minus 5x plus 6. So the common roots would be 2, 3. Now we let that the two other roots of the first equation are alpha beta. So it has 4 roots. So 2 roots are 2, 3. And 2 other we let as alpha beta. Then from beta's relationship, alpha plus beta plus 2 plus 3 is equal to minus 5. If you look at this, the coefficient of x cube by coefficient of x to the power 4 and minus that. And similarly 6 alpha beta, the product of coefficients is 132. That is this term. So 2 into 3 alpha beta is equal to 132. So we have alpha beta is equal to 22. So here if you see alpha beta is equal to minus 10 and alpha beta is equal to 22. So the equation whose roots will be alpha beta will be x square plus 10x plus 22 is equal to 0, which we solve, and the roots are minus 5 plus minus square root of 3. So these are 2 more roots of the first equation. Now similarly we let alpha 1 and beta 1 be the 2 other roots of the second equation. Then alpha 1 plus beta 1 plus 5 is equal to minus 1 and 6 alpha 1 beta 1 is equal to 34. That is alpha 1 beta 1 is equal to, this should be 24. Yeah, this should be 24. There is a typing mistake. Question number 37. So alpha 1 beta 1 is equal to 4. Now once we have alpha 1 beta 1 and alpha 1 plus beta 1, we have the equation, that is there should be power x to the power 2 plus 6x plus 4 is equal to 0, whose roots are minus 3 plus minus square root of 5. So this is question 65. We have 2 typing mistakes. I will fix this in the PDF. Now we solve question number 68. Show that the set of polynomials pk of x is equal to x to the power 5k plus 4 plus x cube plus x square plus x plus 1, where k is in natural numbers, has a common non-trivial polynomial divisor. So if k is equal to 1, in this case, here p1x becomes x to the power 9 plus x cube plus x square plus x plus 1, which is equal to x to the power 9 minus x to the power 4 plus x to the power 4 plus x cube plus x square plus x plus 1. Now here what we do is we take x to the power 4 common. So there is something wrong here. Okay, let's see. 5k plus 4, so 9. We take x to the power 4 common, it will become x to the power 5. Let's say it is typing mistake. Minus 1 plus x to the power 4 plus x cube plus x square plus x plus 1. So in this case, this becomes, yeah, it is a typing mistake. As you can see, it has become x to the power 5 here. So we take x to the power 4 plus x cube plus x square plus x plus 1 common. We get x to the power 4 into x minus 1 plus 1. Thus x to the power 4 plus x cube plus x square plus x plus 1 is a non-trivial polynomial divisor of P1. Now pkx is equal to x to the power 5k plus 4. Yeah, 5k plus 4. There is lots of typing mistake here. Plus x to the power 4 plus x cube plus x square plus 1. Now x to the power 5 minus 1 divides x to the power 5k minus 1. X to the power 4 plus x to the power 3 plus x square plus x plus 1 divides x to the power 5 minus 1. And hence x to the power 5k minus 1. Therefore x to the power 4 plus x cube plus x square plus x plus 1 divides pkx for all k. So we have 2 typing mistakes in 67 and 68. I will fix these typing mistakes. We will look at question number 69 then. So 69 and 70 are similar. I will finish them in one go. Question 69 asks us to find the common roots of equations x cube minus 3x minus 4x plus 12 and x cube plus 9x square plus 26x plus 24 is equal to 0. And similarly 70 asks us to find the common roots of the equation x to the power 4 minus 5x cube plus 2x square plus 20x minus 24, and x cube plus 7x cube plus 8x square minus 28x minus 48 is equal to 0. So whenever you have to find common roots of the equation, you find HCF. So HCF of 69 is x plus 2. So the common root would be minus 2. And HCF of given equation for 70 is x cube minus 4. And hence the common roots are 2 and minus 2. There is something mistake here. This should be square. Okay, if this is cube, the roots cannot be 2 and minus 2. So it is x square minus 4. And the common roots are 2 and minus 2. So with this, we come to the end of this video. And I hope that you are finding this video useful and informative. And I hope that it helps in your studies. So let me know in the comments what do you think about the video, how I can further improve the videos, or if you have further questions, specific questions, or you want videos on certain topics, let me know in the comment box. Thanks a lot for watching. Enjoy.